All right, so now I'm going to do the percent, the mole fraction. So we represent that with a chi, and we usually indicate which item in the solution we want with like a little subscript. So if it asked about, it'd be like that. If it wanted to know the mole fraction of KBr, or it would have been like mole fraction of water if it had wanted to know about the water. Let's go ahead and do it for the water, and then I'll show you how to get to the KBr. Mole fraction can really go either way, especially in Gym Chem 2. They'll like people to practice doing the mole fraction of the solvent, but also the solute. So you just have to be real flexible here. So we just need, it's just kind of like the one above. You just need the moles of what you're talking about of, in this case, it's the solvent, and then over the total moles. And you'll notice this is one of the reasons I went ahead and wrote stuff out ahead of time, because you'll know we already have this information. So again, we have our moles up here. So 0.500, oops, that's our moles of solute. Let's get to our moles of solvent. Here's our moles of solvent over here. We already got that one. 55.5 moles of solvent. And then over the total is 55.5 moles of solvent plus 0.500, and that's your moles of your KBr. Notice it's called mole fraction for a reason. It should come out looking like a fraction. It shouldn't be over 1. So 55.5 divided by parentheses, 55.5 plus 0.5. And that gives me 0.991, because I'm carrying over all my sig figs here. There's no unit with this. It's unitless. These fractions, they're unitless mole fractions. Let's say you got through all that, you reread the problem, and you're like, oh wait, I meant to solve for the mole of KBr. Well, you can go back and fill it all in, or you can just subtract it from 1. Keep your sig figs 0.991. And you can probably do that in your head. 0.009, faster than putting it in your calculator, would be your mole fraction of KBr. But again, you can put it in and work the problem that way. So either way you do it.